Welcome to this pop-up session of Shadow the Scientist. My name is Jamaica Marshall, and I'm very pleased to serve as the Shadow the Scientist coordinator. The Shadow the Scientist initiative is offered by a team at the University of California, Santa Cruz. Today's session will be featuring the CHARA Array, which is the flagship project of Georgia State University's Center for High Angular Resolution Astronomy. And it's optical interferometric array of 6 telescopes located on the incredibly historic Mount Wilson in California. Now, in this session, we have the privilege of shadowing several members of the CHARA team as they are engaging in the mirror recoding process. Now, telescope mirrors need to be regularly cleaned. They have to have their aluminum coating stripped and have a new coating applied in a vacuum chamber. In this session, you'll be able to observe and discuss parts of this process as it happens.
Thanks, Jamaica. That was a great intro. I'm Dr. Nick Scott. I'm the telescope system scientist here at the CHARA Array. Mount Wilson is about 40 minutes above and outside of Los Angeles, California. I'm right now in basically the ground floor level of the 100-inch telescope dome, which is the historic telescope here from turn of the century, 1914-ish. For a time was the largest telescope in the world. And what we are using is the vacuum chamber that was built for the 100-inch telescope. We still use it to recode our mirrors here on site. What the picture I'm showing you right now on my screen is our E1 telescope. So that's the furthest out east telescope of our 6 telescopes. This is from yesterday. And the cylinder, can you see my cursor?
Yes, we can see your cursor.
Okay. So this is the cylinder of the telescope actually lowered down, and this is the way that we remove the mirror. So we did this yesterday, and I'll show a couple photos from that. We rented a telehandler, attach a chain fall to that, and inside the telescope dome, it looks like this. This is our telescope all put together, about to be taken apart. We actually take the entire telescope apart. This thing at the bottom is where the primary mirror is. That's the one that first collects the light and then focuses it on all the other mirrors. It actually gets removed, lowered down, put on rails, rolled outside out to the side of the telescope, and then we lift the mirror out and we lower it down with the crane. So we did this all yesterday. Like I said, the telescope gets tipped over. This is the primary mirror cell here, this white thing, and these are those rails. You see the beautiful view here, San Gabriel Mountains. This is from the other side with the mirror cell lowered onto these rails. The primary mirror is under this black cover. From the underside, it looks like this. This is what's called a wiffle tree. And so it's a bunch of you can't really see the black kind of Y-shaped. And where these bolts here are, above this, there's what's called pucks. And they're on little wires. And that's what evenly distributes the weight of the 1 meter mirror. And those have to all be removed in order to you can see this kind of amber color is the mirror surface itself. And the view out the side of that cylinder is this right here. That's actually looking out kind of toward Mount San Antonio and Palomar is far in the distance. Can't quite see it because of the haze. This is readying a spider that we use to pick up the mirror after it's lowered into its cell. This is the mirror here, and this is one of these pucks. So with it rolled out, this is kind of a view from the distance. And then after removing the mirror, we box it up, we put it in the truck, and we drive it to the 100-inch dome. This is it with a wooden cover over top of it. This silver here, this is aluminum side of the mirror itself. And then did this just this morning, picked it up with the crane and the 100-inch. This is the underside of the mirror with these pucks. And we put it onto this pedestal with the kiddie pool as the protectant. And this is the mirror itself, which you can see is in badly need of cleaning and a coating. We do this, I aim to do this for every telescope every 2 years. And you can see there's, these things are exposed to the elements all night, every night. So they get we can clean them with CO2 with we called snowing them to clean some of the dust off. But, the coating itself actually degrades over time. And you can actually see here, this is with a flashlight underneath the mirror after it's been washed. And you see this is light coming through the back of the coating. So this one's definitely due for a coating. First thing we do is wash it. So we spray it down with water, and the best thing to use is actually your hand. Once your hand's very clean, our fingers are incredibly sensitive, and rubbing it across the mirror is a perfectly smooth surface. You'll feel any little bit of gunk, debris, dust that's embedded in that coating because high winds can embed sand or bounce stuff off, or there's bats and birds and all sorts of things. So we use a type of soap called Orvis mixed with distilled water, and we just rub the mirror by hand, feeling for anything, and just using your fingernail to flick up anything that is stuck on there. And that prevents that being later spread and scratching the mirror. So this is the next step in the process is using hydrochloric acid, a weakened, version, diluted version of hydrochloric acid that removes the aluminum itself. And then after that, removing that coating, this is the mirror itself. So this is the shape, kind of parabola shape of the primary mirror. Still some edges need to be cleaned off. And to do that, chalk is used. Chalk and sometimes potassium chlorate, a base to get anything like oils, and then we also use acetone to get any like oils and residual material off. The point is that we clean the mirror and clean the mirror and clean the mirror again, and at the final stage we wipe it down with chalk, and that helps get a good coating once it goes in the vacuum chamber. So this is the final cleaned mirror. And right now, off to my side, and I'll stop sharing, I'll switch to my camera. We're using the crane to lift the mirror. The vacuum chamber comes apart, and the bottom of the vacuum chamber rolls out on these rails, and we lower the mirror onto that and get it in place. And then it can be rolled back in and the top of the chamber put on, and then it's ready to be put in vacuum. And once in vacuum, there's elements on the top of the chamber that on the inside that are tungsten filaments, just like an old incandescent light bulb. You hang little pieces of pure aluminum on it. And what happens is the aluminum wicks up into the tungsten when it's energized in the vacuum, and then it sputters, a single layer or atom layer of aluminum onto the mirror surface itself. So it's an interesting process. Every telescope facility does this in some way. Not all use 100-year-old chamber. Some use a very modern one, but the principles are all kind of the same. If you want a very thin, even coating of aluminum, and that's your reflective surface on the front of your mirror. We'll also do this for all the mirrors in the chain. So not just the primary mirror, the secondary, the tertiary, the fourth, 5th, 6th, 7th, 8th, 9th, 10th mirror. And yeah, those mirrors are all much smaller and a little easier to handle. You don't need a crane and all that. It's just very carefully carried. Oh, nails. So let me stop sharing, and I'll give you a little bit of a view of what's going on. Oh, I accidentally turned off my camera. Let's see. So let me change the view so I can see better. Okay, so try not to make you motion sick. So this is the mirror being loaded on the crane. And then I'll show you what the chamber itself looks like. So this is where we're loading it. This is the top of the chamber here. And now's a good time if you have any, while they're working on the hardware side, if you have any questions or you might want to go into any more depth of how this all works, I'm happy to chat with y'all. It is quite cold in the dome, by the way.
I was gonna ask. It looks like it's cold there, and of course you're up at a pretty good altitude there.
Oh,
Does it help for it to be a bit cool outside to do this process?
it would actually be better if it was warmer. Any chemical reaction goes faster when it's warmer. So we try and go through it pretty quickly while the mirror itself is still warm. It's been kept in a warmer room. Right now I'm surrounded, like all that's behind me. It's almost like a stadium. It's thick concrete. This is the 100-inch Hooker telescope that we're in the basement of. So it's way above me is the 100-inch telescope. So it's quite cold in here. Surrounded by steel and concrete. So we're trying to go through this process pretty quickly. And those two rooms I showed are heated.
So, uh, those of you who have joined us, thank you so much for being here. We are excited to share this experience with you. Feel free to raise your hand and I can unmute you if you'd like to ask a question, or you can put the question in the chat. And so we did have a question from Richard on exactly which telescope this is. This is the CHARA Array. I know you just joined, Richard. This is the CHARA Array, Mount Wilson. I just dropped a link to the CHARA website there in the chat. So now you said you all started this process yesterday,
Yes.
and it seems incredible that you could get all of that done in just one day.
Yeah. Well, I think on hand, we had 5 people helping. And we've done the procedure quite a few times. We've got it, every time we've got our notes and we go through, but mostly it's getting everything prepped and ready. And it goes pretty smoothly. Of course, we're very, very careful with the primary mirror. That is, in any telescope, the most important part is the primary mirror. They're doing the lift right now. See another question. How much does reflectivity improve? It can improve quite a lot. It depends on what state the mirrors are in. A brand new coating of aluminum, I think it's about 98% reflective, not off the top of my head. And you can lose, 10% over time pretty easily. Usually we don't let them get that bad, but we're every little photon matters, as much light as we can possibly get. So it's always a balance of to do this, because we're part of an array of telescopes. There's 6 1-meter telescopes. So the diameter of the primary mirror is 1 meter. I got answers one of the questions in the chat just now. But since we're doing interferometry, what we do is combine all the telescopes together. So to do this means that one telescope is now out of operation for the removing the mirror takes about a day. The cleaning and stripping and getting it into the chamber takes about a day. And then the recoating, re-aluminizing process takes a few days. So you do it one day and then you let it cure a bit. Lets the coating get hard. And then we need to reinstall the mirrors, which is another day. And then the alignment process. And so aligning has to happen at night when it's good seeing. Rough alignment takes about a day or two or night or two. And then fine alignment, we may need to tweak things, takes another couple nights, depending. It's really variable. It depends. Sometimes alignment goes very quickly. Sometimes it's just very precise optical alignment takes a while. So a telescope is going to be out of commission for at least a week, maybe 2 weeks. And what happens is for imaging and interferometry, the combinations of the telescopes matter. It's actually n times n minus 1 over 2. So if you have 6 telescopes, 6 times 5 is 30, divided by 2 is 15. There's 15 different lines between. If you drew out 6 dots and you drew every line you could between them, you come up with 15 independent lines. And that matters for making images. The more lines you have, the better. So every time you add a telescope, you get a connection between all the other telescopes. So it's not linear. It's not just add one and you get, a little bit better image. You get a much, much better image. So while one telescope is down, we try and prioritize science that is doing other things that doesn't need to make images. Can't always work like that, but that's what we hope for. And we make do with doing 5 telescopes for a couple of weeks. But it's a trade-off of how often you do that, the labor, the risk, because every time you move a mirror, there's a chance something can go wrong. That does happen at observatories. And so we try and balance it out so that we do every telescope gets recoated every 2 years. Sometimes we punt on that if we have other projects. You know, if we think the coating's okay. Sometimes if we think a coating is bad, we'll shift one up. Let's see, there's some more questions. Yeah, we hope for the coating to last at least 2 years. We don't polish the mirror before aluminizing. We do clean it and get it to a perfectly clean surface. It is amazing how much everything is always dirtier than you think it is. You know, every bit of oil, everything, every bit of dust. So it's you know, about an hour of cleaning and prepping the mirror itself. The focus, that's a good question. The focus is not altered mostly because of the design of our telescopes. Let me share my page again, and for people who just joined, I'll kind of go through these photos a little again. So this is E1 with it opened up. So this is a 16-foot wide dome with a 1-meter telescope inside. Sorry for mixing units, but I'm American, which means American scientist means I speak metric and imperial. This light pipe is actually where the light from the telescope goes through all the way to the lab where we do the combination, where all the light from each telescope goes. So each telescope has an associated vacuum pipe. This is the removal. So this is what I wanted to show. This is our custom designed telescope. And there's 4 these long silver rods here. This one is one, and this one at the side, this long straight rod. What that is called Invar. It's an alloy of steel that has an almost 0 coefficient of expansion, meaning that when the temperature changes, most metals get bigger. And when they get cold, they shrink. With these rods, they're engineered in such a way that they don't change shape or length with temperature. And that means that the rest of this telescope, all these black trusses, compress against those rods, and those rods set the distance between the primary mirror and the secondary mirror. And that is what determines the focus of a telescope, is changing the distance between those 2 mirrors. So we don't have to refocus our telescopes very often at all. We will tweak the focus maybe every couple of months, but usually part of that, when I put the telescope back together, we'll align and focus those mirrors. And then they're never touched again for, you know, except for small tweaks, you know, on the few micron size, like, you know, tens of microns at most. So that's part of the process. It's not like your any telescope you may have looked with an eyepiece. You know, there you sit there and you crank the focus knob until you can see a good image. We don't do that with our telescopes. This is it tipped up. But we have 9 mirrors that we're gonna do a recoding on with this session. So the primary, the secondary, the tertiary, which is in the middle, which, let me see if I can find a photo of it. This is the tertiary here, which sends the light off to the side into this adaptive optics bench. Then we have more mirrors there, and others below it, and all this stuff, these more flat mirrors. You know, the only ones that have any curvature are the primary and the secondary. The rest are all flat mirrors just to rearrange the light and get it going toward the lab. Let's see if there's more questions.
Nick, we have a question that you, I think, may not have seen. It was a little bit further up from Daniel. Does it make any difference to the coding procedure that the telescopes are used as an interferometer as compared to a single optical telescope?
Well, that's a good question. Not that I'm aware of. I don't think it, you know, you always want as good a coding as possible. And for us, the biggest thing is that it depends on the wave band you're operating in. So we work in the near infrared and in the visible. So bare aluminum works really well for us. We keep bare aluminum as opposed to like an overcoat or protective coating because we do our own process here, and it just makes it easier to recoat rather than having to have another layer to clean off. But otherwise, yeah, we want as reflective as possible for the wavelengths that we're looking at.
And we have that question from Rob about flexure. Is there no flexure when the telescopes are repositioned after this process?
Well, when we do the alignment, we put it all back together. We put the mirror cell back in actually in this image here. It's a good way to see it. We rebolted the whole truss together against that N-bar, setting that distance, and tighten it all up. And then the alignment is then done relative to that way that the whole truss system was put together. So the telescope is designed to be as rigid as possible to avoid flexure. And there's going to be, every time you take a telescope apart and we relieve all that, once we take it apart, put it back together, it's never going to go back together the exact same way. So yes, there's flexure between recoding, but the alignment is aligned relative to that exact build of the telescope. If that makes sense. So I'm going to stop my share and show with my camera for a second. Now's a good point to look at what we have here. That's the primary mirror in position over the bottom of the recoding chamber. And what they're doing is there's some blocks underneath it. I don't know if they're Delrin or Teflon, but the pucks on the bottom of the mirror have to not sit on the chamber. We want the whole thing to sit, so we put it on these blocks to hold it up. And so there's a lot of like precision of how we align stuff.
So Daniel asked, do you also regularly clean and recode the optics and the beam combiner lab? Which
Nice.
So Daniel visited a while ago. He was most impressed by this. Yes.
The lab itself is an amazing facility. I know, Jamika, you got to see it as well. Yeah, those do get recoded, not as often because from mirror 9 on into the through the vacuum chamber, in the pipes of pan, in the lab itself, a lot of them are in vacuum. So those aren't exposed to the elements. Those coatings don't degrade as quickly. We do recoat them in the winter when we're shut down for bad weather. So from end of December until end of February, we typically are closed because the weather on the mountain is we're in clouds or snow. So we'll do that during that time. That way it's not taking a telescope out of commission. We can't do that with the telescope because to align the telescope, we need to be able to see stars to align with. So those do get recoated, but not nearly as frequently.
From Joseph, why not why aluminum and not silver?
This chamber, I actually asked this morning. This chamber can only do aluminum. And then I think most telescopes now use aluminum instead of silver. Silver, you got to put an overcoat on because it'll tarnish. So aluminum does really well with just no overcoating on it. It'll oxidize, but it'll still be reflective. Older telescopes are often done with silver, but it's a very labor intensive. It's a much more difficult process to do the recoating, and yeah, they tarnish. You can get protective silver. So some of our mirrors in the lab are protective silver. It's a little more reflective in the visible, I believe. No, it's a pure. Sorry, I see a question now. Is it an aluminum alloy? No, it's pure aluminum. It's interesting. It does with the tungsten filament it's hung on. It does wick up into the tungsten and make an amalgam, but then the aluminum sputters off as the tungsten's heated up. Okay, so they've got it positioned right now. Niels is helping with the very precise positioning. You notice that our mirror is kind of dwarfed by the size of this chamber because this chamber was built for the 100-inch mirror. So 100 inches, what, about 2.5 meters or so? So we can actually do all of our mirrors at once for the whole chain. So we're going to put the smaller mirrors next to the primary here as we get them stripped and cleaned off. And you see the top of the chamber there. It's held by a crane on the inside, but it's got the sawhorses under it for redundancy of protection.
Are the cranes just always kind of inside of this building in place for when you need them, or do you bring them in just specifically for this process?
These are built into this building. So the one that's holding the mirror now, sorry for the shakiness, but the one that's holding the mirror goes all the way up to the dome of the 100-inch. So it's used for recoding the 100-inch as well. And then the other one that's holding the recoding chamber is built into the room.
So from Richard, what makes the aluminum attract to the glass of the mirror? Is a charge involved to make that happen?
Oh, that's a great question. Let me ask Niels or Larry when they're. Yeah. Yeah. We need to ask a chemist. We're physicists. It's some sort of chemical bond. It's the it's not so much that it's attracted, it's that it's sputtered down onto it. There's no charge. It's not electrically isolated or anything. I think it's just I know when you take like a tungsten, like an old incandescent light bulb, when you change one, you notice it's shiny on the bottom. When the filament burns out, you look at an old light bulb, it doesn't look like a new one. It's because some of the tungsten has evaporated and stuck to the glass. Um, yeah, I think some sort of atomic bond or I see a question about is the building seismically isolated? No, it's just a massive amount of concrete. Not in the building I'm in right now. The lab is built with isolation between the different concrete pads.
So do you get much seismic activity there?
Not much. We do occasionally get an earthquake, and when, like I've told people before, when we're taking data, interferometric data, we will see earthquakes. I mean, we'll see a car driving by, we'll see a person walking in the lab. It's that sensitive. Anything that changes the distance between the telescopes by a wavelength of light is something we'll notice. But thankfully it's not super seismically active anymore. The San Gabriel Mountains are all decomposed granite, so it's a big rubble pile because of all the past seismic activity. But usually if you get an earthquake, it's pretty small and transient. I think I felt a 3 up here before, and that's about it. A 3 on the Richter scale, I mean.
No, when I was there in the summer, I was so impressed by this entire facility, and especially the historical significance of it all. It was just I could feel the history as you were taking me around during the tour. But seeing this the chamber though was just really incredible. So do you all maintain it, or is that a part of the? Okay, so you all
It's
maintain.
all Larry lives up in the mountain. He's retired from working with us, but he still loves this. He's been up on the mountain for quite a long time, and we're all trying to learn from him of that there's an artistry. One of the reasons I wanted to share this process is this is kind of a mix of the artistry of science. There's a lot here that's just his knowledge and years and years of experience and practice at the best ways to handle different things that come up. So let's see. I'll show you what this looks like. So now they've rolled this together. That's the primary mirror in the chamber. And like I said, this is 100 years old. It's still DC operated blade switches. We will tomorrow actually be like throwing the switches in the chamber to energize the coils. You normally just put this on top of the case, right? Yep. All right.
So Annalise said she noticed a sign for the museum. Can you tell us a little bit about the museum that's there in the background, which I thoroughly enjoyed when
Oh,
I visited?
I can, if we won't make you motion sick, I'll walk you through it real quick. Yeah, so this is mostly a collection of stuff that's up here from different, the operational period of the 100-inch telescope when it was doing science. And also Larry has collected a large amount of stuff. So there's some diffraction gratings. We've got, I think that's for analyzing as spectral lines. We've got a plate comparator. So it's actually compare two photographic images to look for a difference. So if something like Pluto is moving, one of George Ritchie's polishing machines. So Ritchie's a famous optical engineer. Some of the dome wheels for the 100-inch dome from when it was constructed. Now they've been replaced. Quite an interesting collection up here. Looks like a Schmidt camera. the polishing disc for the 100-inch, as well as the crate it was transported in when it was brought up the mountain. So the 100-inch telescope's not used for science anymore, but it's still a public. We have a historic site. The Mount Wilson Institute is who operates the site, and CHARA is a tenant here on Mount Wilson. So this is photos from the 100-inch mirror being brought up. So it's really a unique site. And we've got Einstein up here and Hubble. So this is this 100-inch and the 60-inch telescope was sites of some of the biggest events in astronomy historically. Where learning that the universe was expanding, that these spiral nebulae were actually other galaxies. Let's see.
Thank you for that quick tour. That was absolutely incredible.
I like someone in the comments put about the how the aluminum sublimates, and yeah, that's
Yeah.
exactly right. There's a cloud of gas in the vacuum chamber, so once you vacuum it all out, and then yeah, everything in the chamber gets coated in aluminum. And yeah, the placement of the filaments and that all the filaments are working correctly, that's something that Larry puts a lot of time in, and I work with him on checking each filament. And if you get an incomplete burn in, then you have to redo the process.
How frequently does that incomplete burn-in happen?
Not very common. We did have that happen the last time we did one because there was a problem with our electrical transformer. We've got kind of a custom built transformer, and one of the phases didn't fire, so some of the elements didn't get energized. And so that was a pain, but we got that rebuilt.
We have quite a few comments here.
Yeah, that's great. I don't understand the one about gravity. What I'm not sure what they're asking is gravitationally level. The chamber is not, I mean, it's relatively, I don't know how precisely. But I'm not sure. Love that there's some fans of interferometry. It's an obscure science, but it's incredibly important. We measure the diameters of stars. We image the surface of stars other than the sun, which is something nowhere else can really do. Even in this generation of new upcoming extremely large telescopes, they cannot reach the resolution that we can by a factor of 10.
CHAR's capabilities really are incredible. Can we take a question audibly from Joseph? Okay.
Hello, Nick.
Yeah.
Was just about so I noticed the chains hanging down onto the surfacing thing, and I was just
Yeah.
wondering, is that part of the geometry of the mirror? That's why I
No,
was,
no. It's just a crane to lift the mirror into place.
oh, okay.
Yeah, yeah. Yeah, the mirror weighs a few hundred pounds. So, and that was Victor that just walked by. He does a huge amount on the mountain. He was just operating the crane for us.
So I see Rob here mentions that he visited the array at Mount Wilson, and he's a member of the Stony Ridge Observatory, and they had their mirror re-illuminized in the Mount Wilson chamber a few years ago. I didn't realize that other observatories brought their mirrors there for this process as well.
Sometimes, yeah, and like I said, the chamber is oversized for most of what we can do, so it's not hard to slip in another mirror, and the aluminum, like I think Johan said, the aluminum goes all over the inside of the chamber. So if you have a clean mirror and you put it in there, it's going to get re-aluminized. We can even do 2 CHARA telescopes at once. We just don't often do 2 at once because it's very labor intensive, and often we only want one telescope down at a time. Like I said, it's the combination between them all. In the wintertime, we have before done 2 at once.
Okay, we have another question from Joseph, so I'm going to unmute him. Go ahead, Joseph.
I'm just trying to think more about how it's resurfaced. So it sounds like the aluminum deposition is kind of just a random spray. So are you controlling the geometry just based on how much you're removing
No,
from?
we remove all of the aluminum. We completely clean the mirror down to its substrate. And then the way the chambers are engineered is that the filaments of the tungsten are placed so that it gets a very even coating everywhere inside of it. So basically all we have to do is clean the mirror, put it in vacuum, and the spray happens uniformly.
So is the substrate like some harder material that you can't grind through or something?
No, we don't do any grinding. We just are removing, chemically removing the aluminum. The
Oh,
mirror polishing is set from its manufacturer. We don't resurface, we don't reshape them. None of that here. We're just cleaning off. So it's just the by substrate. It's not glass. It's a type of ceramic. It's not zero dur, but it's another ceramic because these mirrors were made in Russia in the 90s.
okay. So it's just the thin layer of aluminum is like
Exactly.
taken off and then redeposited, and are you polishing it after you redeposit it?
Nope. No, it's perfectly clean after. I'll show you the image of a cleaned mirror. So at the end, so this is what we started with. This is a dirty mirror with poor coating. And you see this is light shining through the coating where it's been worn away. We're up on it's very sandy up here and we get high winds. So it's quite easy, over a couple of years to just the coating wears away and gets etched away by sharp dust. This is a clean mirror. So this is the mirror itself, almost fully cleaned. This last step is just helps. This is the chalk that helps get the last little bits of anything off of it. And this is the mirror before it goes into the chamber. So this is the mirror itself. This is shaped perfectly, or as perfectly as it could, was when it was manufactured. Those circles on it are actually holes in the bottom of the mirror that are for light weighting. So you can actually stick your hand up in them. And then the little shiny bits here are the pucks on the bottom that the mirror actually attaches the telescope with. I see a question about there's no protective coating on the aluminum. We just do bare aluminum. We don't do a overcoat. So it's just aluminum, and that lasts us a couple years.
What's the thickness of the amount of coating that you're putting on? I know you said it's thin, but
It's
how
a few
thin?
few atoms. It's very, very little aluminum. You want it thin because you want to take the shape. We don't. I've not personally measured it, but what I've always been explained to me is that it is just a very thin layer of a few atoms. Like think like when you get something gold plated, that's a very different process, but there's not much gold there, but it's evenly put around, that's an electrochemical process, but it's a very thin layer that's uniformly put around something. This is an analogous type process.
So you said that Larry has an incredible amount of knowledge and that you all are learning this process from him. How do you go about documenting something that has so many subtleties?
Uh, Practice. This is my fourth time, I think, doing this process. Larry's done it dozens and dozens and dozens of times. So, and each time he changes, he is old school, like has handwritten notebooks. So he has huge amounts of documentation of he writes his notes, a full logbook. Carolina and I take notes and thankfully have cell phones and take photos of every step of the process. That helps a lot. Take movies. And yes, I see a question about the white powder's chalk, just calcium carbonate. That's a process that Zeiss Optics developed, and it just gets the last layer of any oil or anything else off, and then you rinse it with distilled water, and it makes sure that you get a really good adherence of the aluminum. Because the problem is, like, if you take that clean mirror and I put my finger on it, and then we put it in the chamber and coated, where my finger was, because of the oil, no matter how clean my hand was, the aluminum's not going to stick. It has to be the very clean substrate.
Is
But
there
yeah,
a
we
particular type of chalk that
just
it's just
from a chemistry supply, just calcium carbonate.
it's calcium carbonate?
Nope. Yeah, we the things we use are calcium carbonate, distilled water, a diluted hydrochloric acid, some reagent grade acetone, and sometimes like a potassium hydroxide or something, a base to take off anything that the acid won't. Because based on what the chemical is on the mirror, different things work to remove it. And so that's where it gets the artistry of like, oh, I know this is this, and I'll put this on it. And then you just very methodically go around and around the mirror and using different optical fabrics, cleaning cloths.
Interrupt.
Yes, please.
The cleaning mirror process.
Yes.
M2.
Yes, I would love to. Okay, so M2 is ready to be cleaned. Nope, not ready to be.
Not ready.
Okay.
We have to set up.
Okay, so we need to set up. But yeah, once it's set up, happy to whatever, let me join in. Okay, so they're prepping M2 to be cleaned, and then I can share that process with you. So let me check on that real quick, and I'll be right back.
Thanks, Nick.
Hey, hello, can you see me?
Yes, welcome.
Hey, hello, everyone. So my name is Carolina, and I'm also working with Nick at the CHARA. And since yesterday, I'm having a great fun because for me, this is the first in my lifetime mirror removal and recording. So this is a lot of fun. It's extremely cold. That's why we are so warm here. So they are preparing the M2, which is the second mirror in the telescope. It's very small because actually it's shadowing a center part of the big mirror. So M2s are always the smallest one mirrors in the telescope. It will take them a few minutes, and then I'm gonna take the laptop there, and we will show you the process how we clean the mirror. We want first to remove all the dust. Actually, M2 is hanging upside down, so it's not so dirty. But M1 is the one that is the biggest one, so it collects the most of the dust. Even though we clean using CO procedure, CO frost, we clean the mirrors every few months. Once every few years, we do have to remove the aluminum from it and make it nice and shiny. As we astronomers can live with dust, but we cannot live with scratches. That's why we never ever allowed anyone to clean the mirrors for us. So M2 is not so dirty, so you won't see it very much of the dust. But on M1, we actually had some bird droppings and stuff like that. That's why we have to clean it. Once in a while, it happens that the bird can sit on top of the dome, which is pretty funny. Yeah, so the whole procedure gets few steps. I don't know how much Nick told you, and for me it's the first time, so I may miss few steps. But first we soak the mirror a little bit with water to get rid of the biggest particles, and then we use the soap, and we actually use our hands to gently soap and clean the mirror with our hands, because only human hands can be gentle enough. I mean, when they were making the mirror for the 100-inch, we are in the 100-inch buildings, or the 200-inch and the Palomar, then we're actually using their thumbs to polish the mirror after the whole process to make it. They didn't have the lasers like the companies are doing these days. So they were actually hanging on ropes above the mirrors and using the thumbs to get rid of every single unevenness, which is a tedious process when you have 100 or 200-inch mirror of diameter. Yeah, so we only use our hands to clean it. Then later we use a little bit of the very gentle acid to get rid of the aluminum. Our aluminum layers are very, very thin, so we don't need to use any heavy stuff. And then we clean it again with water, and then soap it again, and clean it again, and clean it again till all of us are super happy. Then we have to dry the mirror. Most important, what I've learned today is to get rid of everything that is sticky. So any tape residuals, any something that is gluey, sticky, that has to go away, because this will not work in the vacuum chamber. It will absorb all the particles and it will never ever get dry. So I think Nick will tell me. I'm not sure what else I can tell you right now.
Well, we have a quick question that I'm sure you can answer for us. Richard asked, what kind of the soap that you use? Is it a special kind of soap or is it something that's commercially available?
For me, this is soap. Like I said, first time doing this.
Okay.
What kind of soap we are using? There is a question.
Called Orvis. Larry, I don't know where you get Orvis from.
It's used for horses.
For horses?
Yes.
Okay. So this is the secondary mirror.
Okay, do I call it correctly?
Yeah, that's fine.
Okay.
So we don't have a stand for it, so.
So this is the tiniest mirror in our telescope systems.
Yeah. So it's okay to put the shade on this. Back is real dirty. So first we're just gonna clean it with the soap. Should do the hand thing as well.
You can use your hands.
Yeah.
Also,
Yeah.
I said that you can touch the mirror.
Yeah, I know, yeah.
It's exciting part. So
Yeah, the thing you never do is touch a mirror except when you do this.
yeah.
Could you angle the telescope down just a bit so we could see that the mirror?
You can see it.
How's this?
Oh, that's perfect. Thank you so much.
So I'm just feeling it for any like particles or something that could scratch it. Feels fine. This mirror hangs upside down on the telescope, so it's usually pretty good on the front surface. All right, something right there.
Can we use fingernails to scratch it a little bit, get rid of the bigger particles? You have to be super gentle.
I think it's a piece of aluminum. Oh, nope, came off. So there was just a little tiny, felt like a piece of grit, and their fingernail just popped it off. Otherwise, yep, that's really good. I want to clean the back.
You want me to put the mirror?
Oh, yeah. Give a recommendation, Larry, on
Yeah,
procedure. for this?
soap in the spot in the back.
Use your hands if you want. Just-
Probably better.
Yeah, to do without the gloves. This is just the back of the mirror, but it gets dirty because this is the part pointing up in the sky. But any dirt or anything is going to outgas when it's in vacuum, so it has to be, all surfaces have to be completely clean.
Cleaning the whole tooth.
Yep, in the hole. Okay, flip it over. Get some clean cotton. And this mirror is shaped to match exactly with the primary. It even has a certain rotation so that they line up. So they're all paired. And after the light leaves this mirror, it's a 12.5 centimeter wide beam. It's the edge. I got it. Do the sides. Okay, Larry, next. Clean it, and clean it, and clean it again.
But no, I think you're good with that.
Okay.
So you can wash it off with the just plain distilled water.
I get the back and then I'll flip it over. So just washing it with distilled water. Already looks a lot better.
Yeah.
Seems pretty nice. Yeah, but this is one of the mirrors that, I mean, on the only mirror that is upside down, so
Yeah.
it doesn't collect some of that and never.
You can use the acid with the flat.
Okay. And so yours, where'd my gloves go?
Those are yours.
Oh,
But
okay.
I think those are mine.
Where did mine go?
Well, maybe those were.
Anyway. All right, so now gloves and the diluted acid.
Clean button. And a mechanic thing up with on. See it.
You can pick up the laptop and show them.
Oh,
You can go pick it up higher. There we go. Oop, too high. Right there. So
okay.
you can see the coating is kind of starting to come off pretty quickly. Yeah, I can see through the mirror now. This is just starting to remove it, but it's hard to tell on the camera, but it's definitely the coating's coming off.
Okay. You can see how it's changed the color.
Yeah. You shine a flashlight on it. Yeah, really quick.
Actually, you can see the wood already.
Yeah. You can see this is aluminum coming off. Not super exciting, but it's very satisfying.
Sometimes when this. At this point, when it's harder to get off, I might just wanna. Soak
Soak
it,
it.
yeah, and let's just saturate that and let it lay on the mirror. And it helps.
It's like those old TV commercials where they show how old diapers were.
Kind of pat it down to make it. So it's. Physical contact. Well, it's really saturated. thing. And when you lift that off, be careful, it doesn't take the mirror with it.
Yeah. Clunk.
You
Let it pull it out, or let it sit for a bit.
can take it off and use it too.
Oh, yeah, it's much better. So tilt it down a little more, just the lid. Much better.
Here's another.
So actually seeing through the mirror now.
Do it till it's clean, then you do it
Yep.
again, so you can see some.
Yeah, there's
spots.
still little specks, so it's a very repetitive process.
So messy.
Yeah, don't pour acid on it.
Get it on your pad too. That's what I do in the center.
Yeah.
Get it there.
You stubborn flex at the edges. Flex there. Bit on the edges.
Here you go, just concentrate. Little truck is stubborn.
Yeah. So the rest are coming out. Got a couple flex here. Now there's just a couple pieces left. I think the potassium maybe.
Yeah, just.
So This is it now. So you can see straight through it. And we got a couple flecks of aluminum that aren't coming off. So we're going to try the vacuum hydroxide.
Yeah, try,
Just pour that onto some of the
yeah,
more directly on it.
get yep, piece ready. And just put some right on.
There and over here.
Typically around the edges, it's a little bit of trouble. Soak it, down and then right with that. Almost done,
Almost one little fleck left.
probably. Do the last acid wash on it too.
So
Oh, so clean, clean.
yeah, clean and rinse. Clean.
I think you do it for 9 mirrors for each telescope.
I think I got it all. Ready to rinse?
Yes.
Okay, so now rinsing it with distilled water. Now, now it's not a mirror, now it's a lens. All right, Larry, what next?
Well, we can hold it up and rinse both sides. So you know, hold it like that. Turn it over again. Now put it on the pad there, you can dry it with lap towels.
On here.
Yeah. It smells like- What I typically do is um, yeah, rotate it on the towel. Some of those secondaries seem darker than others. Exposure to the UV or light. Okay. Very good.
Where do we want to put it? Straight into the chamber?
Yeah. Just take and do
Just the edge?
Okay.
Okay,
Follow it up and underneath.
gotcha.
Yeah.
That's all it does.
The nerve-wracking part. Go ahead, Larry.
Just lay it gently down on. Right.
Yeah. Good.
I would put it about here. I just had it on top of there.
Uh,
A little bit of water.
Yeah.
Yeah.
There's
a little bit of water on the edge now. Pick it back up and try and dry it.
Yeah, just do it with your towel right there. Okay, well, about three.
Okay. A very clean mirror. Step. Okay. This. That's the process for one there. And then we'll do this for
7 more.
7 more mirrors. But those are the 2 most nerve-wracking.
Watching you carry the mirror from where you were and cleaning it to over to the chamber I was very nervous, and I'm not even there doing anything.
Oh, it's fine. Okay. Take this off. This is just so we don't breathe on the mirrors.
Excellent. I saved all the questions for you.
Great. Let's go through the questions and then got a little bit more time, and then I'm gonna have to go out to the telescope and remove more mirrors and spend the rest of the day doing more of this.
Excellent. We appreciate everyone's time. Thank you. Okay,
Great.
so Ms. Start with Joseph. He had to leave. He's a student at UC Santa Cruz, but he wanted to ask the questions, and I'm going to email him your response. So
Sure.
the first question he sent was, does the wood stand not react with the chemicals and the cleaning and leave fibers on the mirror?
The wood only touches the bottom of the mirror, and also it's very weak hydrochloric acid, so it doesn't really, the reaction's slow on the wood. So it's not really an issue. The top of the mirror, this front surface of the mirror is what we care the most about, and that we make sure doesn't touch anything.
Excellent. And why use mechanical cleaning by hand and not just soak the whole mirror in the acid?
Because any barrier will prevent the acid touching the aluminum. So part of those little pesky flecks are some substance, tree sap, bird droppings, something got on there and prevents the acid directly touching the aluminum. So the little bit of mechanical is just washing it. And
That's
like this, like the chalk is really soft, it's much softer than the mirror, so it doesn't actually have any risk of scratching it.
Oh, okay. I was wondering because the only chalk I've ever dealt with is pretty scratchy when you touch it. It's not soft at all.
It's softer in like a Mohs hardness scale type that you can't scratch glass with chalk, no matter how much you try. And then even then we're very, yeah, this is pure chemistry grade chalk,
Amazing. So Daniel says, this is amazingly hands-on and wonders how the recoding is done with much larger telescopes like Gemini or Rubin or GMT. Is it all done by machines, or do astronomers' bare gloved hands still have a role?
nothing is more sensitive than your fingertips, right? When you're feeling like, I mean, take a piece of glass and you're feeling for any little bit of, I mean, when you feel a bit, I think like a princess in the pea, like a tiny little base of grit, you will feel it with your fingertip, especially when your hands are wet. Like my hands right now are cold and have been saturated in water. They're really sensitive. So just, that's the safest thing. A machine is going to be made of something harder than the glass, whereas I can't scratch the mirror. If my hands are clean, I can't scratch the mirror with them. So it's really a hands-on process. They have more modern coating chambers, but the process itself is pretty much the same. We use a little bit more historical environment, but the procedure everywhere I know is pretty much the same. Hasn't changed in 100 years, I think. And it works. There's one of the things I love and why I wanted to share this with the Shout of the Scientists is there's a lot of art and science is very tightly related, more than people I think realize, and the way it's portrayed in media. And this is the the difference. Carolina put it really well of like in baking, you can follow the recipe, but even the recipes say a pinch of salt, and that's where the artistry is.
Yeah,
And that's very much the
is teaching us, telling us slowly, gently use that. He says he tried to measure how much choke he puts to water or anything, but then in the end, it's the matter of feeling it has.
Yeah, he's adjusting for the temperature, the humidity, for how long the mirror's been sitting, how old the acid is, how long it's been in the jar. Like he just has done this so much, and so it's really a kind of an apprenticeship process.
I'm so thankful that we were able to shadow you and Carolina and Larry during this process. Nick, thank you so much for sharing this with us. And so now you are going to head out after our session and continue this process. When do you think you'll be finished with all of the mirrors, getting the recoding done?
We'll be done cleaning them and stripping them by the end of today. Larry loves doing this, and so he said he may be working in the evening on it. We'll stay as long as we can to help him. The smaller mirrors go much faster. As you saw with the secondary, it didn't take very long. And then go on the chamber. Tomorrow we'll do the firing of turning the switches on the chamber and recoding. The biggest time process for that takes the time for pumping down the vacuum. I can take you real quick and show you the vacuum pump. We still use a quite old pump, but Larry also maintains that, and I'm working at learning all of his process. So this is the roughing pump that will pump down that big chamber, and then we have a higher vacuum pump on the inside that's more modern. But this is the earlier, and it works quite well. So he understands how that works. And then the last step is the there's an oil diffusion pump. So there's some really cool stuff when you get into high vacuum technology of how these pumps work, that you heat up droplets of oil inside a chamber, and they adhere to the molecules of air and condense it and bring it down. So it's a really cool process that Larry knows. I'm a PhD astronomer. I'm not I've never done much with other than, oh, this is the pump, you turn it on, it works. So actually learning how this stuff works is really fun. It's very hands-on, as you've seen. But yeah, we'll do that tomorrow, and then we'll leave those to harden. Let the coating just harden onto the surface and wait for better weather. Right now the humidity is a little high, so we need low humidity to open up the telescope dome and to take the mirror out. And we'll reverse the process that I showed the photos of putting the mirror back in. That takes a day. So earliest we'll put the mirrors in and be ready to align. It's probably Monday. And then Rob and Carolina and I will stay up all night for a few nights in a row and make sure the mirrors are all aligned. And that's a whole other process.
That's an incredible process, and I'm so thankful that we were able to get a sneak peek at a part of it.
Yeah.
Richard asks, what is Larry's title? Now, I know you said Larry is retired, but
Larry's title that he's very proud of right now is retired.
That's what he puts on his
Yeah, he has
ID cards.
Yeah, every time we have a meeting.
Event.
Yeah. He reminds us that he does what he wants to work on, which is this stuff, and that's where we're trying to get all the information we can. He lives on the mountain, actually, just on the other side of the lab, with his family. Before he retired, he was the CHARA site manager. So he handled all the daytime stuff of anything from
Where's the screwdriver?
Yeah, we're
Something is
tools,
leaking.
deliveries, fixing stuff, heaters are broken, just a little bit of everything. Before that, before working for CHARA, he worked at the solar observatories up here on Mount Wilson. So he, for decades, worked at the solar tower, doing solar observations. I think he was a technician there, but I do not really know.
But in general, Larry is the walking encyclopedia about the whole facility here.
Yeah.
He knows all the stories, and then he's amazing in talking them. And we are trying to get him in front of the camera.
He does not want to be in front of the camera. So
We are trying to find the technology how to drain his brain and get all of that.
so any comments on YouTube should be directed at me for criticism, not at Larry.
Understood. Well, thank you all so very much for sharing this experience with us, and everyone in the chat. We're grateful for your incredibly brilliant and insightful questions. So Nick, I know possibly in late December or January, we may have another session where you'll show us some pictures and maybe some videos from the rest of this process a little bit later. Is there a place where, before we have that session, where you all will post some of the pictures from the process?
Maybe I thought about that.
Probably we haven't thought about that, so we can definitely organize something and share some nice pictures with you.
Yeah, we can figure out something, but at the very least, we'll have it that we'll make a video montage and maybe a photo collage of the process.
But
That sounds incredible.
We'll need some time for that.
Yes.
First, we have to get the telescope operating again.
Yeah, first priority is always the science.
Absolutely. Well, we'll look for that sometime, maybe towards the end of December, and we'll Shadow of the Sciences will definitely share it as a teaser before we have our next session with you. Nick, Carolina, Larry back there, thank you all so very much for your time and sharing your expertise, giving us this insight into the mirror recoding process. We look forward to our next session with you.
Yep, and happy to do more sessions. We'll do some of observing science. We also have our CMAP telescope, our 7th telescope. We last week buried the fibers for that. So that's connecting optical fibers to all our telescopes.
So if somebody thinks what astronomers do is staring at the telescope, no, we do the digging.
We dig ditches too.
So
You do the actual digging to lay the fibers.
yes, so we are in general paranoid and we don't want anyone else to break the fiber.
The fibers couldn't be pulled. They had to be hand laid and they
Yes.
can't be twisted. And each one is about, what, $50,000?
Exactly. So
so-
there was 10 people just step by step carrying 600 meters of fibers.
Yeah,
But
so-
I think that can be an exciting session to
But yeah,
to share.
we have a lot of ideas for sessions, so we'll be in touch. Happy to do this anytime, Jamaica.
I'm looking forward to it. Thank you all so much and wishing you success in the rest of this process.
Okay, thanks so much. Thanks, everyone. Those are great questions too. Bye.
Aloha.